Okay, so for part C, you're finding, for the particle described in part B that we just did, find the position vector in terms of t, find the velocity vector at time t equals 1.5. So before you get started, you want to know some of these givens. So like I talked about before, conversion from polar, so you have x theta equals r theta cosine theta, and then y theta equals r theta sine theta. And then from parametrics, how you find your velocity, you have the points dx over dt and then dy over dt. So those are two things that you want to make sure you know before you get started. So first off, we're going to start with the position vector. So for the position vector, we know it's xt and comma yt. So this is from what we just did previously. You're going to plug in that 4 minus 2 sine theta, and then plug in the theta equals t squared into the equation while also using your conversion equation. So you're going to have 4 minus 2 sine t squared times cosine t squared, comma 4 minus 2 sine t squared times sine t squared. So those are your 2 points. And then from that, you're going to find the velocity. So your velocity, is dx t over dt and then dyt over dt. So you're going to use your calculator and use nderiv, and you're going to plug in these 2 points that we found before. So this xt and this yt, and you're going to plug it in, but then you're going to make sure your x is equal to 1.5. That's what's going to make your answer be accurate. So once you plug in these equations and find their derivative, you should get for dx t over dt negative 8.072, and then for dy t over dt you should get negative 1.673. So basically that's just how you do it. You're basically using your calculator for a lot of this, but you want to make sure that you know these givens. They're not given to you in the problem, but you should have these memorized. Your conversion from polar to your x and your y, and then your parametric equations and your how to find the velocity.